So, starting on question number 16, this is part 3. Which of the following functions have the zeros listed below? Thing to remember always, first off, is that parentheses are liars. They lie to you in terms of what the actual sign is. So, minus 7 should be x plus 7 in factored form. So, we know right off the bat that A can't be because this isn't a plus. So now we have B, C, and D. And now we move to 8/9. So if we think about how you find zeros, this guy right here is x equals 8/9. You could go through on B, C, and D and just solve those and see which ones give you that. And that's totally okay. So you could set 8x minus 9 equal to 0 and solve. You could do it that way. What I want to do is I actually want to solve the function backwards. So I want to solve it until I get it equal to 0. So I'm going to times 9 times 9. So that has 9x equals 8. And then I minus 8 on both sides. So 9x minus 8 equals 0. So I basically went from the 0 and solved backwards until I got to that. So I should have 9x minus 8, which eliminates B. And now I'm between C and D. And here, if you remember, to get an imaginary number, the plus or minus 3i, you need a plus in here. So right off the bat, that could tell you. And if you get stuck, just solve them. So if I solve C here, so x squared minus 9 equals 0, plus 9. If I take the square root, that just gives me plus or minus 3. Cool. Now, let's do it for part D. So I know it's not C. Let's make sure it's D and not C. So plus 9. So if I minus 9, if I take the square root, I'm taking a square root of a negative number. So that's what gives me the plus or minus 3i. So it is D. So it says, what is the end behavior if I have a function here? And with end behavior, we need to know if its leading term is positive or negative. So we need to know the leading term and the degree. Like, is the degree even or odd? So to do this, let's just go ahead and multiply these out. I'm going to multiply the negative in, so I'm going to have f of x equals negative, take my bracelet off. Negative x plus 5, and then x plus 7. If I distribute that out, I'm going to have negative x squared minus 7x plus 5x plus 35. And then if I combine like terms, I have negative x squared minus 2x plus 35. And in all reality, all we need is this leading term here in the front. And I know, like, since I have a negative, I know that my leading term is negative. And here, my highest exponent is 2, so it's even degree. And I know for negative and even degrees, it looks like this right here. Something like that right there, which the fancy way to write this out is that so my limit as x approaches negative infinity of f of x is, so as x goes to negative infinity, as x goes left here, I'm looking at this guy right here. I'm going to negative infinity as well. And then same with even degrees, they always have the same one. So the limit as x goes to positive infinity of f of x is also going to be negative infinity. Okay. And you can refer back to the chart that we made on number 10, this chart right here. So that brings us to the the free response questions. So all the questions up to this point would be multiple choice, and now we move to free response, and we have this. So for f of x equals this, answer the following questions. Find the absolute max and the absolute min on the interval 0 to 2. So for A, so max and mins occur at endpoints and turning points. So max and min occur at endpoints and turning points. So for you all, just go into your calculator, second trace, find the max or min. But for me, I'm just going to use Desmos because that's what I have access to. So Desmos. My function is negative x squared plus 3x plus 2. So I'm just showing you on the Desmos calculator because that's what I have access to on my iPad. You all use the TI-84s that we normally use in class, plus 3x plus 2. Okay, so from 0, and then 2 is somewhere like right here. 0 to 2. 2 is like right here. And my turning point is at 1.5, 4.25. You all can find that with second trace max. So let's write out. I've got my endpoints. And when x equals 0, if I plug in 0, to my function, that gives me 2. So my endpoint is 0, 2. My output value, the absolute maximum, is talking about the y value. So my y value here is 2. Let's try my other endpoint. My other endpoint is at 2. So x equals 2. Then y equals, plug that into my equation. Then y equals -4 plus 6, 8 plus -4, so 4, 2, 4. Make sure that's right on the graph. So do the math really quick. Yep, 2, 4. So 2, 4. And then my turning point that I found. Then my turning point, my max or min. In this case, it's a max, and it was at x. I can just write out the coordinate because your calculator will give you that. And then that is this right here, 1.5, 4.25. 1.5, 4.25. So now I have the different points. My 3 different points, my endpoints and my turning point. So the absolute maximum, it's talking about the highest y value. So I have an absolute okay, and then my absolute and notice, you're like, Mr. Hampton, well, if you look at the graph, the absolute max and min, it goes down forever. Like I can look at this and my graph's gonna go down forever. Well, it's talking about the absolute max and min on the interval 0 to 2. That's why it's different. And then what are the real zeros of x? So once again, you could factor this out, or on your calculator, you would go you would graph it and then second trace 0. So you would find the 0 values by using your calculator here. Second trace 0, second trace 0. So I'm going to do that with my calculator, like you all are doing the same thing. 3.562 and negative 5.62. So my zeros. So I have zeros at x equals negative 0.562 and x equals 3.562. Right. Just make a check on my work. Yep. So I have zeros there. Zeros are just, in most cases, are wherever it touches the x-intercepts. So that's for part B, because it wants the real zeros. I can have imaginary zeros, but I know by the fundamental theorem of algebra that because this is a degree 2 function, so highlighted in green here, that's a degree 2 function, the maximum number of zeros is 2. And I've got 2 zeros here. So I've got a 0 at this and this. So that takes up all the zeros that I have. So when it asks me here, what is the maximum number of non-real zeros for f? Well, the max number of non-real zeros is 0 because all zeros here are real x-intercepts. Okay. Basically, I know that there has to be 2. You could also include that. And I know the max number of zeros for a degree 2 function is 2. Right. I've already got my 2 zeros. I can't have any more. I'm out of room. Okay? So that's my answers. So just a hint on the test, you're going to be looking at an odd degree. So odd degree functions are going to have an odd number. They're either going to have 0 or odd numbers of, or like pairs of complex zeros. Sorry, I'm mistaken myself. So odd degrees, like conjugates always, imaginary numbers always come in conjugate pairs. So you might see something like if you factored it out like x plus 3, x minus 2, x squared plus 16. This right here is going to be 2 complex zeros. 2 complex zeros. So just be on the lookout for complex zeros because there's a good chance that the one on the test, hint, hint, will have a complex 0. So now, this is kind of ugly because Delta Math printed off weird, but let's walk through the problem. Mr. Hampton likes Oreos a lot. He likes them so much that he decides to make up a function about them for his AP Pre-Calculus study guide. Wow, look at me go. So he finds a function that measures how he dunks Oreos into a glass of milk. The function he finds is h of t. So let me highlight this so we can come back to it. So h of t is equal to this, where on this time interval, and here h of t represents the height in inches of the Oreo with respect to the glass of milk. So height is h, and then t stands for time in seconds. With this situation, answer the following questions. So how deep does the Oreo get dunked? What I would do on all of these is change h of t to y and t to x and graph on calculator. Okay, I'm gonna graph it on my calculator. So that becomes y equals x minus 2 squared minus 1. So if I graph that function on my calculator, I'm going to have something like this. You all type it into y equals, like, it's going to look something like, let me do the math real quick, x minus 2 squared. Let me make sure I get an accurate drawing. So, and we're going to need this anyway, so x minus 2 squared minus 1. Is that my function? Yes, it is. Okay. 5, 3, and yeah, making sure. So your function looks something like this right here, okay? And it wants to know how deep did the Oreo get dunked? And at what time does this happen? How deep does the Oreo get dunked and at what time does it happen? Well, the deepest is going to be the farthest below surface, because if you think about it, if I got a glass of milk here, I'm not a very good artist, but I got a glass of milk here. We're going to say we have some yellow milk. It's kind of funky. We've got this yellow milk here, and we dip the Oreo in. The deepest that it gets is going to be when it breaks the surface here. So the deepest point is going to be my minimum. That's a fancy way of saying find the minimum here. And we found that that was, like with your calculator, that's 2, -1. That happens at 2, -1. And here, we know our x value represents the time, and that this represents the height, because that's how our function is set up. So h of t is my height, and then t, my independent variable, is my time. So if we think about this in context, we can write this out as the Oreo gets dunked, and we're measuring from the tip of the Oreo. It's not precise, but it's okay. Gets dunked 1 inch into the milk at t equals 2 seconds. Okay. B. It says, at what times would the Oreo be at the surface of the milk? At what times would the Oreo be the surface? Because once again, we're tracking our height here. So let me change colors here. So if I think about it in green, as I'm starting here really, because it's from, my function is only defined for the interval 0, 4 here. Circling that a bunch of times up here, 0, 4. Okay, my function is only defined at 0 to 4. So I start at 0 here. This is my starting height. So I slowly go down, and then the height is with respect, because it says the height with respect to the glass of milk, right? So the x-intercept, this x-axis is really where the milk starts in the glass. So here, whatever this x-intercept here is, and here, this x-intercept, that is when it's breaking the surface. So if I think about this then, it's not want to work with me here. So my x-intercepts here, you can do second trace 0. My x-intercepts are going to be at 1 and 3. So in context, let's see what it says for B. At what times would the Oreo be at the surface of the milk? The Oreo is at the surface at 1 second and 3 seconds. Okay, C. Then, is the Oreo dunking pattern concave down or concave up? This is why I think it's helpful to draw my graph like we did in part A. So highlighting it here in yellow. So this little drawing that we made here. And also, not really like you don't have to do the drawing per se. If I just look at my graph, Like say you're just looking on your calculator here. That's concave up like a cup, not concave down like a frown. So this is concave up like a cup. That's how we remember it. Concave up like a cup, concave down like a frown. So this is concave up, concave up. And make sure you answer in sentence form. I'm just doing shorthand. Concave up. And what does that tell you about the rate of change of that function? Okay. This tells me, concave up means the rate of change. This tells me that the rate of change is increasing on this interval. Okay. Then D. What is the average rate of change on the function for the interval 1, 2? So write your solution in context. So my average rate of change is delta y over delta x. And from 1 to 2. So f, or I guess in this case, my function is h. So I should write h of 2. My bad. H of 2 minus h of 1 over 2 minus 1. And that's going to give me h of 2. You can plug it in. So plug into my function value here. So h of 2 is 2 minus 2 squared minus 1. So negative 1. Negative 1 minus h of 1 is going to be 1 minus 2 squared minus 1, which should be 1, I think. 1 minus 2 is negative 1, squared is 1, or is that 0? I'm tired at the end of the day here. Let's see. Let's check my math here. So h of 1 should be 0. Yep, 1, 0. Perfect. So h of 1 is 0. So plug that in. 1 minus 0 over 2 minus 1 is 1. That gives me negative 1 over 1, or negative 1. And then for part D, it also tells us to write your solution in context, which means this. It's telling me about the rate of change. The rate of change here is how fast I'm dunking the Oreo, the speed of my dunk. So the speed of the Oreo dunk decreases on average, because it's average rate of change, on average, by decrease comes from the negative, and then what am I decreased by? 1 inch.
JC Lucas, if you're still in the building, you have something to pick up in the front office. JC Lucas, something to pick up in the front office, please.
The speed of the Oreo dunk decreases on average by 1 inch per second on the interval 1 to 2, because this is talking about my time here. Okay, so there we go. Let's crush this test.